Nice to see you. Buongiorno. Good morning, everyone. Sabah el khair. It's very nice to see you all this morning. I think we will take a few academic minutes to see if further people join us before we start with Dr. Chrysostomou's presentation this morning. Good morning, Axel. And Sabah el khair to all our colleagues from Qatar. Very pleased to see you again this morning. As I said, we take a few moments, a few academic minutes, perhaps not an academic quarter, but a few moments to see and give a chance for our colleagues to join. I hope everyone is well this morning and well and healthy in these times. This is very much, of course, in the fall. And Hari, I assume your presentation is all set. So we just wait for a few moments for further people to join.
Yeah, I will share my presentation now.
Yeah. Okay, just a moment, Hari. I'll let's wait to see further people to join, and then I will give you a cue to share.
Thank you.
I have suggestions to Kersey and to the others. The two rooms, instead of being separate, since the number of attendees is less, why we cannot join them in one room? What do you think?
Tell me again, Dr. Karaibe.
I was thinking, since we have two rooms and the number of attendees is not that high, so we may have the two rooms together as in one session.
This is
I don't know, what do you think?
Yes. Axel, I saw you in agreement. So this is and also Andrea. I assume Gianluca and Alexander are also in agreement. I think it's a good idea. So we also have the opportunity to stretch the sessions a little bit, because as you see in the end, we have the discussion and closing remarks, which is rather comfortable in terms of the timing. So what I suggest is we could indeed have them back to back so everyone can benefit. Is that okay with everyone? Yep. Okay. Good. So
Yes,
I think I think we will adjust the program slightly. So we will have the breakout sessions actually one following the other, and the allocated time is half an hour, but we can stretch it into the next session so we can take it organically, which is the last session discussion and closing remarks. Another point, between the talk by Professor Al-Rausch and the tutorial by Dr. Lausi, I suggest we take the group photograph, and we could also have a small break in the program at some point. Perhaps we could take it in the same occasion where we take the group photograph to have a small break after that. How does that sound? The other option is, of course, we can take a small break after the tutorial. There are two options, either one hour into the program or then let's say 1.5 hours or so. Is there any preferences? Now that we have a good group, we can adjust things. Okay, I think we are ready to start. So Sabah el khair again for all of our colleagues in Qatar. Professor Al-Garadawi, it's very nice to see you this morning. Sabah al-Khair. We have Professor Garaibe and several other colleagues from Qatar today with us, as well as our BEAT team. So this morning, we will have the pleasure of hearing a talk from Dr. Haralambos Chrysostomou, who is, of course, a colleague here at the Cyprus Institute. Let me introduce him briefly to you. He is an associate research scientist with expertise on advanced machine learning and data-driven applications. Dr. Chrysostomou focuses on methodologies for analyzing, storing, manipulating, anonymizing, and distributing big data. Dr. Chrysostomou is currently working and publishing on several applications on machine learning, including characterization and classification of data, genomic and proteomic analysis, fluid dynamics, as well as medical imaging. Dr. Chrysostomou has organized multiple workshops and special sessions related to machine learning and big data analysis. And currently, Haris is the leader of Work Package 7 of the BEATS project that deals with all aspects related to data acquisition systems, 3D tomography image reconstruction, data analysis, data management, archiving and policy, as well as computing infrastructure of the tomographic beamline at SESAME. So there's no better person than Haris, of course, to talk to us today about data analysis and management for the beamline for tomography at SESAME, BEATS project. So Haris, we are eager to hear your talk. Please do share your slides, and floor is all yours.
Thank you very much, Christine. I will try to share my presentation now. Can you see?
Yes, we can.
Okay. Thank you very much for the introduction. As Kirsty mentioned, I'm an associate research scientist at the Cyprus Institute, and currently I'm the Work Package 7 leader for the BEATS project, which deals with data analysis and management. For this presentation, I will focus on the data analysis and management on itself, but more specifically from the point of the users on what aspects of the computing infrastructure we are currently in designing and building, and how the users can be benefit from this infrastructure. First of all, the overall goal of the Work Package 7 is to deal with all aspects related to data acquisition system, the 3D tomography image reconstruction, the data analysis system, data management, archiving, and policy. These all aspects it's important in regards to have an operational and beamline and the computing infrastructure to keep the tomography beamline up and running. This is particularly important for this beamline because this is one of the most computational and challenging tomography beamlines in regards to data generation and what is needed to collect this data, be able to analyze it, storage, and archive this kind of data. Also, we have some policy-related aspects that we need to deal with as data ownership and data access and archiving. So before I go into the presentation, I would also like to mention the other participants of this work package, which is the European Synchrotron Radiation Facility, ESRF, the Synchrotron of Light and Experiment Science and Application in the Middle East, SESAME, the Cyprus Institute, and also the Paul Scherrer Institute, PSI. So all these partners are involved in the core operation of this work package, and 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 they all contribute with their expertise. When we talk about data analysis and management, and more particularly for Beamline, first of all, we have to prepare and endorse the SESAME data policy. It's the rules that will govern them, not only how the data will generate, but who has access to the data, who is the owner of the data, and so on. Then we have the task for hardware and software definition, depending on the expected users and the expected data, the amount of data generated from this Beamline. We need to define not only the hardware, but also the software needed in order to have a working Beamline, and not to only collect and reconstruct the data, but also serve the users with their needs in terms of analysis. Then when we have designed Beamline in terms of computing infrastructure, then we need to procure the hardware and install it and test it. That means we have to keep in mind the tomography applications that the user will need to use it, and then adapt the data generation and pipelining in order to serve the users in regards to their specific applications. And finally, we have the data analysis as a service, which is a collaboration between Cyprus Institute and SESAME in order to serve the users, not only on the side of the two institutes, SESAME and the Cyprus Institute, but also due to the era of now the COVID pandemic, to be able to do it remotely from their countries. Okay, first of all, I will start with the first aspect, which was the SESAME data policy. And then the data policy more specifically will govern the data ownership, data curation, data archiving, and open access to data. This data policy is already ready and endorsed by the SESAME Council in June 2020. So this document will be available to the users and available to the SESAME website in order for the users to have it as a guideline when they generate their data, who owns the data, how they can access the data, with some associate metadata, and so on. So we define the limits of how much, because there is some storage limit and process limits on the infrastructure, so the user will know for how long the SESAME will be able to store their data, and what it has to be done in order for them to be able to transfer their data in their same institute, and what it means for data archiving, what it will be held by the by SESAME for as much as possible, hopefully indefinitely. So this is a very useful document, not only for SESAME to define the rules, but also for the users to know not only their obligation, but also their rights in terms of the data generated. Then I will continue in the hardware and software requirements. In this, we had to follow standard guidelines already followed from the other synchrotron facilities, and then specifically find these guidelines in order to accommodate specific scientific cases that SESAME expects from its users. We anticipate a number of experiments per year to be around 20 to 25, so we'll be able to at least accommodate 20 to 25 experiments at this Beamline per year. We had to define the computing powers, not only CPU but GPU, and the special needs that this is in the era of the COVID pandemic. We have to accommodate special needs for online data processing. We have to define the storage sizing depending on the output of the camera, how much data we can collect from the camera, and then also consider the future needs of the Beamline, and to be able to accommodate current and future needs for the specific Beamline for the users. And then by taking because this is not something that we designed from the beginning, and then we have entirely from the beginning, you have to take into consideration the available hardware and software available at the SESAME. And also we have some dedicated resources from our side, which is going to, I will explain by the end of this presentation, how not only SESAME can use it, but also how the users can use the infrastructure and the resources from both sides, SESAME and the Cyprus Institute side. When we talk about the software, hardware and software pipeline of the Beamline, we talk about first of all, the acquisition of the raw pixel intensities from the camera. And then we need to have available the software, the infrastructure to the users and SESAME in order to do some raw data processing, which is meant flat field correction, scenogram creation, and so on. And then we go into the reconstruction of the 2D or 3D of the samples. That means Fourier-based iteration or some more advanced iterative algorithms. And then we have the 3D volumetric data, which is going to be available to the users. What we can promise is the pipeline until here, which is the minimum that we need to provide to the users. But we wanted to push a little bit further and to provide some software and some specific pipeline that is going to be used for specific applications, which is going to be like volumetric data processing, which is conversions of data types, noise reduction, ring artifact reduction. And we want to go through some utilities that the user can use in order to do segmentation and quantification of their samples. And this is some of the examples that we can do, like thread holding, region growing, and so on, or geometrical measurements of the size, shape, orientation of the samples, and so on. This we will aim to provide the entire infrastructure available to the users, and we are going to provide dedicated hardware and software for the users in order to do this kind of analysis. This is a more specific diagram regarding the available hardware, which you are going to have the experimental hatch, where is the camera located and the actual experiment will happen. Then we have the bit control hatch, where we will have the data acquisition system for the data to be acquired. And then this will go into the back end of the pipeline, where you will have the GPU and CPU cluster, where the actual heavy it's heavy in resource, needs a lot of resources, where you can have a GPU and CPU and GPU cluster, where you will do the pre-processing, reconstruction, and so on. So this is the heavy lifting of the computing infrastructure. And then we have the short-term storage for the users to store their results and the raw data for further analysis. But this is a short-term storage that it will be connected at a certain time and will be transferring the long-term storage. But the users will also have available the data analysis and visualization workstations, which will install a specific pipeline that we would like to do a holistic approach, where we'll have enough software there and enough computing power to cover the majority, if not all, the applications that the users will want to implement. So everything, the majority of the visualization will be done in here at the data analysis and visualization workstation. Furthermore, I would like to go into more specific about the hardware and software required. So, as I said before, we have the short time storage, where the user will keep their own data and the reconstructed data for a certain time This certain time is defined at the data policy, as I mentioned in the beginning. And then after this certain period, the data will automatically be archived in long-term storage. And this will be available hopefully indefinitely. And then the user will be able to request the data even after a certain period. But the user will have the option to take not the option, they are required to take their data with them. So the storage for this short-term storage is, we define it to be half a petabyte would be enough for the first few years. But we also have the long-term storage, which is based on tape-based systems. And these two systems would be enough to accommodate the anticipated number of users for the first few years. But we also always have in mind that this system will be upgraded if more users are, hopefully more users will use this Beamline, and we have the option to always upgrade these storage systems. Next, we have the software. For the reconstruction, we settled on two softwares in order to give more flexibility to the users. The Pi HSTC, which is used currently in ESRF, and Tomography, in order to do the reconstruction and produce them tomography slices and volumes from the experiments, from the samples. Currently, this is an ongoing process. So this software, currently we initialize the pipeline with this kind of software, but we are always flexible to upgrade this software if needed, and if the specific application from the users demand. For the visualization workstation, we are going to equip it with tomographic data applications, and here we are going to name a few, like Dragonfly, ParaView, 3D slices, Port 3D, IMOF, and ImageJ. And the aim of this is to use the majority of the software to be free and open access. So we have some applications that are paid and will be available for the user at SESAME site and the Cyprus Institute site. But the majority of the software is going to be free and open access, so the users will have an easier access and to be able to download them on their own institutes after they leave SESAME or the Cyprus Institute. So they will not be restricted in a closed system where they have to use very specific software hardware in order to do further analysis in their experiments. Another important thing is to have a remote access to the Beamline control and data acquisition system, as well as to the visualization workstation, and this will be granted on demand even after the users leave the SESAME. And then also they will have the option to use, I will explain how later on, how to access also the Cyprus Institute infrastructure in order to do further analysis on their samples and for their applications. This is a more comprehensive list of software that we are going to install on the most SESAME site, but hopefully on the Cyprus Institute site, where you have the city reconstruction, as I mentioned, PyHTS 2, but we are going to have NABU and TomoPy and so on. So the user will not be restricted in one application, and then they will have more flexibility. And as you see in the open source slide, all of them is open source, and the user will be able to use this kind of software on their own. They don't need to be at the facilities. Furthermore, we also have 3D data processing and visualization, which is like ImageJ, ParaView, Dragonfly, and so on. Also here, the majority, unfortunately, not every software is free. But the majority of these software are open source and free to use by anyone, and then you can download it even now freely from the internet. And here is the links that you can use in order to access this software. Okay, and this always will aim to have in mind the application of the use. In order to do from the computer tomography to simulations of virtual experiments. And this is, thank you, Gianluca, for these wonderful slides of different applications. Is for data analysis as a service. This is important because there is a synergy between the Cyprus Institute and SESAME in order to connect these two institutes and to do and offer this data analysis as a service. Currently, in order to do that, we need to have a strong infrastructure regarding network connectivity. And then what we plan to do is that the Cyprus Institute currently has more than half a gigabyte of direct internet connection, but we have plans to upgrade next year to 1 gigabyte of gigabit per second by the end of 2021. We also have the Cyprus Institute is part of SciNet, which is the Cypriot NREN at the national member of GEANT. And SESAME is part of JUNET, the Jordanian NREN, and also a member of the Arab states RNE network. So instead, not only the user will be able to have access directly to this to both institutes, but they will be able to SESAME and Cyprus Institute will be able to utilize these two networks in order to transfer their data. And I believe other institutes will be able to utilize these two networks in order to have faster transfer of data between institutes. Okay, currently for storage and computing infrastructure, currently here at the Cyprus Institute, we have the new machine called for high performance computing called Cyclone, which is a supercomputer with peak sustained performance at 600 teraflops. We have 33 nodes available and more than 20 petabytes of long-term storage, which is available. This infrastructure, we are going to use it in order to serve the needs of SESAME for the BIT project, and we plan to do it in two folds. The first one is to have them development and testing in a proprietary on-demand access, which is going to be available for Cyprus and SESAME staff for the code development, and in order to develop the infrastructure of the software infrastructure for the BIT's Beamline. This is already applicable, and SESAME already has proprietary access to Cyclone. And also for the users, which is more important to you, the user will have production access to the machine, where they will have access to the entire machine in order to do the computation, to do their experiments. And this, how much resources is going to Cyprus is going to devote to SESAME is going to be defined by their expected users. So this is going to be reviewed every 6 months, and the resources will be updated. The availability of resources will be updated. But you have to keep in mind that this is a high-performance computing, so we need to follow the rules for a high-performance computing system. And we will be able to provide training to the users on how they can use a high-performance computing system. So usually you don't have access directly, but you enter a queue, but the entire system is available to you when it's the turn of your experiments. This was my presentation. Thank you very much for your attention, and hopefully you have some questions I will be able to answer.
Thank you very much indeed, Hari, for this presentation on the data management and data analysis for the BEAT project. And at this point, I would like to open the opportunity for the participants to ask any questions from Haris. Are there any questions from the floor? Or are there any questions in the chat?
I have a question regarding possibility of mathematics, it can be useful, or add some interested mathematicians that can do something in data analysis, or only the users, the experimentalists, either physicists or engineers or material scientists, only they do not need that very specific mathematical tools, like in Fourier analysis. Maybe some of the users, they do not have that background. Do you think that mathematics professors in Qatar University also can be helpful or not?
Are you thank you for your question. Are you talking about specifically the SESAME infrastructure or the Cyprus Institute infrastructure, or both?
No, I'm speaking about the users. Users like me, I'm not good in food analysis or all of that. So the software packages will do this for me, or I need
Yes,
some...
the software is going to be, we will have keep in mind that the user will not be expert in this kind of analysis like Fourier, Fourier-based interval reconstruction and so on. The software will be, the pipeline for the reconstruction specifically will be automated. So the user will not be able to, will not be directly involved in that aspect. What you can be involved is the further analysis after you have your 3D reconstruction. And I think Gianluca is the Beamline scientist, would be, I believe he can provide a little bit more further information.
Yes, if I can add to that, I think you rose a very important point. Tomography beamlines are naturally, or by definition, a place where mathematicians can have an important role, and a place where research in mathematics and informatics is happening. So there is every day new algorithms for phase retrieval, ring artifact correction, and reconstructions coming out. So you are right. If there is someone interested from departments of mathematics or informatics in Qatar would like to involve and take part in a student project or in a research project, BEATS will be the place where they can test the algorithms and acquire data for as benchmark. So we would be very happy to discuss that. We cannot hear you. Dr. Garaibe, I think you are muted.
Yes, please unmute yourself, Dr. Garaibe.
I'm sorry. My last question is, many thanks for the information. I will share your message for colleagues in mathematics, if they are interested, or informatic department in College of Engineering. The last question that I would like to ask is, as a new users, you will train them about the available software, how to do the analysis while they are in SESAME, and later from Home Institute. You will give some training or something like that, workshops or something for them?
Yes, training will be provided to the user in order to be able to complete their experiments. So I think the training is going to be, I believe, in two folds. One for to use specific software, and the other one is to understand because you have specific software for specific applications. So I think with the Beamline scientist, Gianluca, you need to identify what is the expected outcome, what you want to derive from these experiments. Then you have to identify which software is, and also not only software, but which how you can perform your experiment, because I believe there is different way you can do the experiment with the camera, and then with the help of the Beamline scientists and SESAME, you will be able to guide into the correct direction, and then use the correct software and provide training in some extent on how to use it even after you leave SESAME. So training is very important part of this process. I don't know if Gianluca, you want to add something?
Yes, maybe to that, what one should add that we should keep in mind that the pool of users visiting tomography Beamline is very diverse. So you would have one day someone from geology, one day someone from biology, and the other day someone for cultural heritage. So providing training and knowing the software needed for all these applications is simply impossible. So there are some steps that are common, opening the data, segmenting the data, some basic image processing steps that are common, and that we will train, of course, and provide support on those. But then it's very important also that the user community, when a certain user has some expertise in one of these applications, it is very important that the user itself gets involved, gets in touch early enough so that we can discuss the application before the beam time, because otherwise it's impossible in 2-3 days of beam time. You sit at the machine and you do the measurement, and at the same time you cannot perform the training in data processing, right? I think it's very important that we start feeling responsibility for this Beamline, and that different users come together as well, because there might be overlaps. So one community might have a certain expertise that can be transported to another community. So for this, we have to start early enough. In fact, even if the Beamline is operative only in 2023, we have benchmark data from other Beamlines. So already next year, for example, we could start discussing pipelines, discussing the available software, testing the available software. So the key message here is get in touch in proper time, much before the beam time, already next year, for example.
Okay, thank you.
Thank you.
Further questions, comments, points for discussion? Yes, Dr. Hanoun, please.
My question is there any bottlenecks for the storage? For the RAM, you have 256 gigabytes in the acquisition system, which is great. I want to know what's like the bandwidth for transferring these images from the RAM to the storage, because this will govern dynamic tomography experiment. For example, with the 256 gigabyte, you can, like if a single stack is 8 gigabyte, you can collect like somewhere around 30 volumes. For example, if you're doing 10-second scans. So I want to know if there is any bottlenecks for transferring the data from the RAM to the hard drives, and this will govern like the dynamic tomography experiment.
Yes, there is a bottleneck, but not from the RAM of the system. It's from the camera, because there is a maximum amount of frames we can capture from the camera from experiment. So the bottleneck is there. The system was designed to capture everything that the camera can produce. So and there is a limitation of the RAM, but you have to keep in mind that this is not stored temporarily in order to keep up with the camera. Then we can have a direct transfer of the data into the short-term storage system, which you can start the process also of reconstruction. So this is not a step-by-step process, but this is a pipeline. So you can stream the data. And I believe that currently, and I believe Gianluca can correct me, the bottleneck is on the camera side, not on the computing infrastructure. So I think we can.
Yes, my question is exactly when you transfer from the RAM to the short-term storage? What's the bandwidth?
It's 14 gigabits per second, I think, that connection. So it would be more than enough it would be more than enough to transfer the data from one system to another.
But Harry is correct. So the standard way in which this camera operates is you are provided by the camera supplier, for example, a backend server with a RAM which is large enough to store your acquisition. So which means that if you go in 4D, at a certain point you will reach the limit of that RAM. We are lucky enough that we can actually collaborate with the Paul Scherrer Institute and the Swiss Light Source, where they have developed data acquisition pipelines for much faster cameras. They have 9 megabyte, 10 megabit detectors that are streaming with much faster speed. So they cannot rely on such a concept, and they have to stream data directly to the storage in the server room. And this is what we will do. So we will bypass the RAM of the backend server. We will have a buffer-based backend writer where we can stream directly on our GPFS, which means that if we do not saturate the speed of the switch, we can in fact stream as much as we want. You're not limited by any RAM size. Of course, if you have some experience in informatics, this is all very much relying on the specific implementation. So since the implementation will be different than the one in PSI, we cannot already we need to build it and benchmark to say, okay, this is our sustained data stream speed, because any software implementation relies on the hardware behind it, right? But the goal is in fact not to be limited by the RAM size of the backend and be able to stream continuously without interruption if you are interested in 4D studies. I think for 4D applications, in fact, what Harry said is right. The limitation will come from the exposure time and by the camera. So for 4D studies, the limitation will be the 100 frames per second that the camera can take. And if you can live with 10 milliseconds exposure time, which also depends on how dense the sample is and so forth.
Yes, thank you very much.
Any further questions, comments, or items for discussion at this point? If not, thank you for all of you for your questions, as well as for those of you providing answers, and thank you, Harry, for again for your talk. Now it's time to introduce the next speaker, Professor Riyad Al-Raoush, who is based at Qatar University. Professor Al-Raoush is a professor of environmental engineering at the Department of Civil and Architectural Engineering at Qatar University. His research interests include the fate and transport of contaminants in subsurface systems, environmental fluid dynamics, multi-phase flow through porous media, and environmental soil physics. Professor Al-Raoush secured more than $3 million in research funding from agencies such as Qatar National Research Fund and the US National Science Foundation. He has published more than 50 peer-reviewed papers in top journals in his field. He is a frequent reviewer for many international journals in the area of environmental engineering, water resources, geophysics, and geoenvironmental engineering. He was a visiting researcher at US national laboratories, including Argonne National Lab, the Pacific Northwest National Laboratory, and Los Alamos National Laboratory. And Professor Al-Roush will talk to us today about synchrotron microcomputed tomography for geoenvironmental applications. Professor Roush, it's a pleasure to have you here with us. The floor is all yours. Professor Roush, you are muted currently. Could you unmute yourself? And yes, let's begin from the. Okay. Yes, we can hear you now.
Okay, assalamu alaikum everyone, and thank you for the opportunity to talk about our research applications of computed tomography. We listened to excellent talks yesterday and today morning on the use of computed tomography and its advantages. So the focus of my talk is going to be on the applications of computed tomography for geoenvironmental engineering. So I will focus on the applications. I will talk about pore scale experiments and image processing and analysis. So synchrotron computed tomography can be used to study a wide range of energy and environmental applications. So here are just examples of some of the investigations that we did in terms of environmental applications. We did experiments related to physical and hydraulic properties of granular material, groundwater artificial recharge and dewatering, fine migration in subsurface systems, and contamination with colloids and petroleum hydrocarbons. For energy applications, we did related work to enhance oil recovery, methane hydrates, microbial enhanced oil recovery. And this is just an image that represents a sample obtained from computed tomography. So you can see that we have three phases. We have the oil, solid, and fine phase. So why microscale? Many environmental processes and phenomena take place at the microscale level or the pore scale level. Therefore, to better understand these processes at the larger scale or the macro scale, these processes or phenomena must be investigated at the pore scale. This figure here shows an illustration of how contaminants transport through porous media from underground tank towards a fresh groundwater aquifer. As you can see here, mass transport mechanisms of contaminants take place at the microscale level or the pore scale level. Therefore, there is a need to obtain non-destructive 3D images at the resolution of microns to observe and investigate microscale processes for different applications. So the overall experimental approach that we adopted here is we design and conduct microscale experiment based on the application of interest. We obtain non-destructive 3-dimensional high-resolution images of systems at different experimental conditions, and we develop and implement robust and efficient algorithms for image processing and quantification of the relevant pore scale processes from the large 3D images. So why synchrotron microcomputed tomography for our applications? Synchrotron microcomputed tomography is an imaging technique that provides non-destructive imaging, 3-dimensional high-resolution images on the order of microns, And most importantly, energy is tunable to obtain better contrasts between the different faces that we have in the images. So this figure here shows a top view that illustrates a typical tomography beamline. The sample is mounted here, and it passes, X-ray passes through and around the sample, and the sample rotates around vertical axis with a specific angular increment. Then the projection passes through the scintillator and then reflected by a mirror toward the CCD camera. This image here, it's part of our experiment that was conducted at the Advanced Photon Source at Argonne National Lab in the United States. What you see here, this is the image of the 6 giga electron volt storage ring. And these pictures here shows some of the experimental setups that we developed and used for 3-dimensional images for different applications. And I will talk about these shortly. While all the 3-dimensional images obtained, while all the images obtained from tomography are 3D, this image here shows 2-dimensional cross-section. It just shows different faces inside the column. This slide here shows the experimental setup that we use to conduct multi-phase flow experiments. In these experiments, CO2 was injected into saturated porous media and was imaged at different CO2 saturations. Monochromatic X-ray radiation was used to scan the specimen, and the injection of CO2 took place on the moving stage. As you can see here, the setup was equipped with top and bottom ports, which were linked to tubes that allowed fluid flow. The bottom port provided gas, while the top port was used to drain water in order to allow gas to invade the pore space. Vertical springs here were added to apply stress to the porous media. Image C here, the 3-dimensional image, shows a 3-dimensional image of the interior of the object where CO2 is shown in blue and the sand is shown in gray. Here, to enhance the contrast of the faces of the image, what we did, we doped the water by adding 2% of potassium iodide to enhance the contrast of the faces. Then the sample was scanned at 2 different energies, below and above the iodide edge. You can see here the image size is about 2000 by 2000 by 1000 voxels. And it took about 15 minutes per scan to complete the experiments. And the resolution of the image that you see here, it's about 3.6 micron per voxel. This is the setup, the experimental setup that we used for hydrate formation and dissociation experiments. The setup was designed to control the pressure and temperature to simulate the formation and release of hydrate from deep reservoirs. Pink beam synchrotron tomography was used to obtain non-destructive 3D images. Pink beam uses a grazing incidence mirror and an X-ray absorbing foil instead of the monochromator to eliminate high and low energy photons, which gives a high flux of X-ray 3 orders of magnitude higher than the monochromatic beam. This was necessary for our work because the X-ray needs to penetrate the thermal insulation that we have in our sample and the high pressure cell that we used for this setup. The total time for this experiment was about 12 seconds, the scanning time, and the experiments were run for more than 4 hours for hydrate formation and another 4 hours for hydrate dissociation. This is another experimental setup, a series of experiments that we conducted related to multi-phase flow in porous media. The objective of these experiments was to investigate patterns of fluid entrapments and their correlation with the physical and chemical characteristics of the porous media. Here, the setup shows the experiment, I mean, the column that we use or the cell that we use. The inside diameter of the column was about 6 millimeters and the height of the column was about 8.5 centimeters. The column was connected to tubes and pumps that allows fluid injection into the cell, and different porous media or different sand was used to represent natural porous media systems. We used different fluids, including synchrotron, water, to represent immiscible fluids in the experiments, and to investigate the impact of wettability of the entrapment patterns of the fluids. Fractionally wet systems were obtained by combining various mass fractions of untreated and treated sands. The experimental cell was packed with porous media at different initial conditions. One of the advantages of synchrotron tomography is that the energy can be tuned to enhance the contrast of the phases of the image for a better segmentation of the faces or the images. To utilize this advantage, fluids used in our experiments can be doped with certain chemicals, and then the systems are imaged at energies just below and just above the edge of certain elements. For instance, in our experiments, the oil was doped with iodobenzene and the water was doped with cesium chloride. And you can see in this system here, the image was, or the system was imaged at 2 different energies just below and above the edge of iodide, which gives a good contrast of the oil phase in this image. Once we have 3-dimensional images obtained from computer tomography, image post-processing and segmentation are needed to convert grayscale images to binary images, so we can work with them and we do some quantification. So there are many segmentation algorithms available that can be used to achieve the segmentation step. Also, there are different filters that can be used to enhance the quality of the images. So for instance, in this case, we used anisotropic diffusion and median filters to enhance edges and boundaries of the faces before the segmentation step. As I mentioned, there are so many segmentation algorithms available, and this is very critical for our analysis. So here what I show is just an example of image segmentation technique, which is indicator creaking approach. In this method, basically faces are identified based on the histogram of the intensity of the values in the image. You can see here, this is a grayscale image obtained from computer tomography that has 3 phases: sand, water, and oil. And this plot here shows the histogram, the corresponding intensity histogram of the image. The segmentation is done based on the 2-point correlation function. So for example, values below T1 are assigned to one phase, between T2 and T3 are assigned to another phase, and values above T4 are assigned to a 3rd phase. And the uncertainty here is between T1 and T2 and T3 and T4. In this case, we use 2-point probability correlation function to identify the phase. In this slide here, I show the outcome of an algorithms that we developed and used to identify individual particles of systems of granule material using 3-dimensional images obtained from computer tomography. This enables us to obtain complete characterizations of system at the particle level. This is very essential, very critical in many engineering applications such as force transmission, failure mode, and so on. What you see here, this is a 3-dimensional output of the code that we developed and used for identification of individual particles from 3-dimensional images. Different systems are used here. This enables us to obtain complete 3-dimensional characterization of the systems at the particle level, which is very critical to engineering and environmental applications. This is another application or another series of experiments that we did. We conducted experiments to investigate the stress-strain correlation and the impact on the particle displacement and evolution of the pore space. These are 3-dimensional images obtained from computer tomography. These are real-time experiments, and we look at the increment of stress-strain at different times and different stress increments, and this gives us critical information for geotechnical engineering design and applications. These are some of the measurements that we can obtain from 3-dimensional imaging in non-destructive way. This is extremely important for our applications. So for example, figure 1 here shows the distribution of grain diameters in a sediment sample. And figure B and C shows the distribution of important shape indices, namely the sphericity index and the roundness index. And you can see here, these are the 3-dimensional images of these distributions. And everything here is done non-destructively, which is, a critical factor in our research. This is another series of experiments or another environmental application where we use synchrotron microtomography. Here we looked at the distribution of trapped fluid in different geometries of the porous media. You can see here, let's see if I can see my pointer. Yeah, so here we looked at the distribution of trapped fluid in different geometries of the porous media. From 3D images, we can obtain complete and accurate characterization of the trapped fluid as a function of the pore space. The inside diameter of this column is about 1 centimeter, and this data is very useful application to enhanced oil recovery, remediation of contaminated groundwater, and so on. You can see that this gray here is the solid, and this white here is the oil phase. This is another three-dimensional image. It's an outcome of a computed tomography experiment that we conducted. We looked at the trapped blobs in the pore space. The size of the sample is 1 millimeter by 1 millimeter by 1 millimeter here. This image shows the distribution of individual blobs, and you can see these are identification of discrete or individual blobs. From this system, we can obtain parameters such as, length, volumes, directions, and these can be used as input to models that predict processes such as mass transfer. These are three-dimensional images obtained from computed tomography experiments. We looked here at the impact of wettability of porous media on the characteristics of the trapped blob in the pore space. Again, these are non-destructive images. The size of the sample was 1 millimeter cube. These images show the identification of individual blob and the impact of wettability on the distribution of these residual blobs. This is another experiment where we use computed tomography. We looked at the dynamics of hydrate formation and dissociation in porous media. We used xenon gas and was injected into a full saturated sediment at a temperature of 10 degrees centigrade and a pressure of 1.9 megapascal. These are cross sections from 3D images where the inside diameter, again here, 1 centimeter. These images shows how we can capture the development of hydrate as a function of time. You can see that this gray scale here is the porous media or the sand phase, and the white here it's the hydrate formation as a function of time. This video here shows a sequence of raw tomography images captured continuously at a time step of 45 seconds. This shows the hydrate dissociation at the pore scale and how parameters such as volume, interfacial area develop as a function of time and saturation. Understanding and quantifying these parameters at the pore scale, it's a key factor to develop reservoir scale or macro scale models for natural gas production from methane hydrate. These segmented images shows the outcome of the hydrate formation experiments. You can see from these tomography images, three-dimensional images, we can identify 3 types of habitat formation, namely we have surface coating here, we have cementing here, and we have pore filling here. Such observation in non-destructive fashion is very important, not only to predict gas production from hydrate methane sediments, but also it's important to evaluate the safety and the structural stability of hydrate reservoir. This is another study where we use synchrotron microtomography to investigate the impact of pressure on the gas conductivity in sandy sediments. So for the same geometry of the porous media, for the same topology and geometry, you can see that here we can quantify 2 types of flow regimes at low pressure here. You can see that gas phase is highly connected. However, at this low pressure or at this high pressure here, you can see that the gas phase gets disconnected to individual or multiple gas blobs. This is another experiment. We use synchrotron computed tomography to investigate the impact of the type and the percentage of clay on gas flow or in unconsolidated porous media system. As can be seen here, we have three types of flow patterns. In figure A, we can see that at low content of clay, the gas is connected and flowing in a capillary fingering behavior through the sediments, this one here. And in figure B here, we can see that at high concentration of colonite, you can see that the pore space is clogged, which in turn causes microfractures. In figure C here, you can see that at high concentration of moronite, this is another type of clay, the gas is disconnected, which in turn increases the residual gas phase saturation. This is zoom for the type of behavior that we see if we inject clay in our system. You can see that gives us information about the clogging behavior. You can see on this image here, the clusters of clay or colonites are observed to be attached on the sand-water interface. So we can identify what type of interface we have here. And actually this causes clogging of small throats, which in turn gives gas-induced microfracture. However, on this image here, moronite is observed to be attached at the gas-water interface, and that causes disconnected gas phase and okay. This image here shows the impact of the type of clay on the flow of gas in porous media system. We can see here in this image, colonite causes gas flow is a continuous phase. This one, this red one here. However, in this case here, you can see that another type of flow, which is moronite, causes gas to flow as a disconnected phase, which in turn increases the number of trapped residual gas phase in the system. You can see that here, every color represents a different gas phase. Pore scale modeling is a powerful technique, powerful simulation technique that allows understanding of single and multi-phase processes at the pore scale. So three-dimensional data from microtomography is essential to validate predictive pore scale models. So two methods are available here, the lattice-Boltzmann modeling technique and the pore network modeling technique. Lattice-Boltzmann method utilizes or considers the full complex geometry of the porous media or the pore space, which gives accurate predictions. However, it's computationally expensive. On the other hand, the pore network modeling here uses a simplified geometry of the pore space, and it gives reasonable prediction of the pore scale processes and phenomena. Here you see the simplification of the complex pore geometry to the pore network structure, which is the base for pore network modeling. This pore network structure is used for pore network modeling based on the physics of the relevant problem of interest. You can see that this is a simplification of the void space. In other words, the pore bodies connected to pore throats. There are so many algorithms we use or actually available to obtain the distribution of pore bodies and pore throats. And you can see that in this image here, these are the pore bodies and these cylinders are the pore throats. So we can follow the physics of the fluid dynamics in a sample like this one here, so we can build predictive models. This slide here shows an example of the outcome of pore network of a sample of unconsolidated porous media. So we see here pore size distribution. You can see here throat size distribution. You can see here coordination number, which is the number of throats connected to a pore. And what you see here is the throat length distribution. And these distributions, as I mentioned, they are used as input for pore network modeling approaches. This is an actual microtomography image from an experiment that we did. You can see that this one here, this is the gas phase through the porous media, and this is actually the pore network. Is it this way? This way? Yeah. Here we use computed tomography to obtain three-dimensional, non-destructive measurements of tortuosity of soils. Tortuosity is an important pore scale parameter that describes the flow paths in a porous media. So you can see here, these are the flow paths. This is two-dimensional cross-section out of this three-dimensional image. You can see that these are the paths of if the flow comes in this direction towards this direction here. And this one here, these are all possible paths of a given fluid if it's injected at this point here to this point here. This is actual computed tomography image, and this is one of the algorithms that we developed to obtain tortuosity. These are some just images of pore network structures. And here I show the analysis of representative elementary volume analysis for porosity. The REV is the smallest volume of a given sample where the property of interest is constant regardless of the spatial location of the size of the sample. In other words, it is the minimum size needed for a sample to be representative in terms of a given parameter. So using non-destructive three-dimensional images obtained from computed tomography, we can determine the REV of a given sample. Here I show the REV determination. Basically what we look at expanding volumes, and we look at the parameter of interest. In this case, it's porosity. So whenever the property of interest is constant, so we consider this an REV minimum, which is the minimum representative volume for upscaling. Here I show the representative elementary volume for different soil samples. And as I mentioned, the finding or determining REV is a link between the pore scale and the macro scale simulations for any geo-environmental applications. I would like to thank Qatar University, Qatar National Research Fund, and Argonne National Lab, my collaborators at University of Tennessee, Chongbuk National University, South Korea. And I would like to thank my colleagues, Engineer Jamal, Professor Khalid, and Professor Jung Wong, and Dr. Zahir Jarrah. Thank you so much, guys, and please let me know if you have any questions. Thank you.
Thank you very much indeed for most interesting talk. We are very pleased to have you with us. And at this point, I would like to ask the audience if there are any questions for Professor Al-Rawsh following his talk. Are there any questions, any discussion points, queries that you would like to?
Actually, I would have one or two questions, if I can.
Yes, please. Do go ahead, Gianluca.
First of all, thank you very much. The talk was very interesting. I think it's very promising for us to see already such a broad and diverse expertise in computed tomography. So I wanted to know, you showed several time-resolved studies, which of course is very interesting. For many of them, I have the feeling that the time resolution and the speed of the experiment was something that we could do at Beats. You showed one example where the different time steps were separated by minutes. So you were tracking a process over 15 to 20 minutes. I think it was in gas formation. You also showed an example of strain evolution in a granular mix. What was the speed of that experiment? Was it also like minutes, or was it faster than that?
Professor Rausch, I think you are muted. We can't hear you.
Okay, now it's good. Can you hear me now?
Yes.
Yeah, sorry, I'm using the computer of my student here, so I just moved here. Anyway, thank you. This is a very good question. So for the hydrate-bearing sediment, we are looking at the development of the hydrate, and the scanning time for the experiment was 12 seconds, and the running time was 4 hours for development of the gas and 4 hours for the dissociation. So it's about 8 hours of the experiment. But the time of the scan is about 12 seconds.
And what about the mechanical test with the granular mix?
Jamal, I'm sorry, question again.
What about the mechanical test? You showed a mechanical test of a sample with a mix, a granular mix, where you were tracking the strains.
Okay, so that was, I think it was about 25 minutes. Yeah, it was 25 minutes. Yeah, the scanning time. Because we want to reach to a quasi-state equilibrium.
Mm-hmm. Maybe one more question, if I may. You also showed experiments done with K-edges, so energy resolved and probably image subtraction. Those were done on a beamline with a double crystal monochromator, I imagine.
Yes, yes.
Okay.
What happened is our interest here, we just want to make sure that the doping percentage does not change the physical and chemical characteristics of the material. So we did some preliminary investigations. So we found that 2%, 2 to 3% is appropriate for our fluids. That does not change, parameters such as density, viscosity, surface tension, and so on, because these are very critical to our experiments. So. And we use different materials such as cesium chloride and iodobenzene and so on.
Okay, thanks a lot.
Thank you.
Further questions, comments, or queries at this point? Can I just check, Hugo, if there are any questions on the chat? Mm-hmm. So, of course, the applications for the BEATS beamline will develop during the time that the beamline is being constructed. If I could ask Professor Al-Roush a question of how specifically do you see that if you do indeed see that the BEATS beamline could provide opportunities both for your research group and in a wider sense for Qatari researchers in your domain and perhaps even beyond. Could you please unmute? I'm sorry, it's muted at the moment.
Thank you, Jamal, for the help. Okay. So can you hear me now?
Yes, we can.
Okay.
Thank you.
Yeah, it's a very good question. Actually, I see advantage that it's pretty close to the area. So instead of using beams in the United States, so beamline here will give us, reasonable access. That's one thing. And I see here there's a lot of applications in Qatar, like oil and gas industry, environmental applications, geo-environmental applications. So there's tremendous applications that can be used or they can be applied. They use computer tomography to obtain, three-dimensional non-destructive imaging. So I see a lot of opportunities, and I hope that will work out.
Thank you very much indeed. Further comments, questions for Professor Al-Roush at this point? We will, of course, have an opportunity to discuss further in the last part of today's program, in the discussion section, both in terms of Professor Al-Roush's talk, as well as other talks that have taken place both today and tomorrow. So unless there are further questions at this point, I would very much like to thank Professor Al-Roush for your presentation. And it's really a pleasure to see these applications and the relevance that BEATS beamline can also provide access to the relevant techniques for these type of applications in Qatar. So now it's time to take the group photograph. So if I could invite everyone to who wishes to turn on their videos so that we can ask our IT specialist here to take the photograph. So let's take a few moments to rearrange the video displays. And this also gives me a chance to thank Belkis Meha Abufaur, who has just appeared on video there. She has been, of course, the person who has contacted you on the occasion of this meeting and borne the brunt of the organization. So Belkis Meha, thank you so very much for all the logistics, all the organization, and I'm sure all of the participants are happy to join me in thanking you for your efforts. Belkis is now based in Istanbul and is able to join us from there remotely today. So I take it now that everyone who wishes to turn their videos on have done so. So Mr. Angelos, if you could take a few shots. Okay. Great. Yes, very good. Thank you very much indeed for everyone. Now, question to all the participants. Would you like to have a short break now, or shall we continue with Andreas' tutorial for applying for beam time and have a break afterwards? Axel, what do you think? Break now or after Andreas' talk? And of course, Andrea, we should ask you as well whether you wish to have a break now.
I have no strong.
Pardon?
I said I have no opinion.
Anyone else? Is there a need for a short 5-minute break at this point? Okay, let's continue, and then we have a short break before the further discussion in terms of the now back-to-back sessions that were originally breakout sessions. But let us continue now directly to the next part of the program, which is Dr. Andrea Lausi's tutorial. He has prepared for us a tutorial on how to apply for beam time. And this is, of course, a wonderful opportunity to hear from the SESAME scientific director, the best person indeed to tell us about the ways in which one can be successful in beam time proposal construction. Andrea, floor is all yours.
It was not easy to find out where to unmute if you have already started the presentation. So, screen, yeah, I suppose.
Yes.
And also hear my voice, otherwise you didn't answer. Very well. We were at this point, yeah. We left yesterday with the news that SESAME is the only advanced light source which is fed by a solar plant, the EU actually, and sorry. Yeah, so what we do with this, we inject every day. SESAME is not a top-up machine, so we have a decrease in the intensity of the beam during the day because of electrons running and hitting residual gas in the vacuum pipe, and so we inject every day. But apart from this 1 hour, half an hour, depends on chance and the idiosyncrasies of the machine, essentially it runs like every synchrotron, 24 hours a day, 7 days a week, and which means that the users are an essential part of this process, because if the beamline needs to be attended, we need to have enough users to stay also during the night, or to program the experiments in such a way that it is run automatically during the night. This is the last year, the first actually, and the last year more or less regular beam time available. I didn't want to share for this year because it's a bit depressing because of these lockdowns and coronas and shutdowns, and so essentially you see that the pink period, which amounts to roughly 3,000 hours, is the amount of beam time which is given for experiments. The green parts are shutdown of the machine for installation. A young machine, we still have things to be installed, like at the beginning of last year, there was the wiggler. Then from time to time we have also some other things that has to be put into operation, and so you have meantime in blue and shutdowns in green. This is the suite of beamlines which are or will be soon available at SESAME. The first three are there in place and working. So we have an XFS beamline. You can use hard X-rays, atomic structure of materials without the need of a crystalline structure in between. You can have infrared spectroscopy to identify the chemistry of your samples, and you can use the new powder diffraction material science, it's called, but beamline, which is now starting working. I saw the first pattern of silicon standard, and so that is also working. Then there will be very soon, which means 2022, a fluorescence beamline in the soft X-rays regime working, the HESEP beamline, and in 2023 we will have beads and a photoelectron spectroscopy beamline in place, thanks to this Apple II modulator and the 3-pole wigger, which are installed during next year, both of them, actually. And then plans are also for a macromolecular crystallography beamline and for a SAX beam in the future. Let's say when Fund is will be secured. All of the end, like every synchrotron, we transform light into scientific papers. In our case, it's a two-step process. Sun to energy to from the machine, photons from the machine to papers. And to answer one of the question of Dr. Cavie, this is the iceberg of the work of the beamline scientists at SESAME. So there is a visible part which is hosting the users when they are here and allowing the experiment to be conducted, but there is also the submerged part which is interacting with them they have left, helping in the data analysis, because the synchrotron radiation techniques are not widespread yet in the region. So XFs and this is just for XFs and IR. As you see, practically all of these, except one of these papers have a SESAME author in it, because the beamline scientist was not there only to open and close the shutter and allow the people to take the the data, but it has also been involved in the data analysis, in the preparation of the samples, and in some cases also in the write-up of the article itself. So this is a long process, but this is the end at the end of a synchrotron, let's say, using the. So how do you start instead? Okay, if you are a new user, the first thing that you have to know is that you can participate. So SESAME has an open access policy. There is no restriction of the nationality of the users. Everything will be based on scientific merit, and so good proposals will always find a way to. This gives you an idea of what has been done and what is being done in this moment as at the various beamlines. So these are the 3 calls that we had. It's called call 0, which was in 2017, just before the beamlines entered into operation, which received a total of 55 proposals, which doubled 1 year later, when 1 year and a half later, Beamline, XS and IR were already functioning, and we went up to 103 proposals. With the opening of the third beamline, not only we maintained or even increased the numbers of the already open beamlines, but we also had the first numbers coming from the powder diffraction beamline, and so we ended up with 151 proposals, which puts us in a situation in which we prolong in this moment the plans were that we go to a semester by semester working scheme, but for the time being, and especially in this Corona time, this transition is far from happening, and 151 has been selected, and 75 of them will be actually measured, which is a healthy ratio between accepted and proposed, and it will end, since we have to go to mail-in now, since nobody is going to travel to Jordan these days, unless not for the few days of a proposal, at least, then it's just on the shoulders of the beamline scientists. The beam time, we cannot afford to have people here at night because we don't have enough, and we cannot afford to have people working 7 days a week because we don't have enough staff, and so this call 2 will keep us occupied until the end of August 2021. The next call will be launched in March 2021 for measurements to be done after September 1st, 2021. So how to apply? You go on the website. On the top right, you find For You, and From Users brings you to the SESAME user portal, which is where you have to register in order to apply for beam time. So once you have registered, there is one thing here. During the registration, you will be asked your institution. If the institution is not in the database, which can menu, you write an email, explain so that we can keep the number of institutions to have a binary identification of an institution. Otherwise, we would have, for example, quoting the place I worked for several years, we would have Elettra, Elettra Synchrotron, Trieste, Trieste Synchrotron Elettra, and so on and so forth, with 10, 15 institutions, which are actually the same one. So this is a little tricky thing that you have to do. Then, once you are in, first of all, you will receive our newsletters and our at a certain point, you will receive an email that opening a call has been opened. Yeah? So you will be able to submit a proposal. Entering at that point will let you find this button, submit a proposal, which was not there before. And at that you fill in the data which are requested online. You download a Word template which has very clear instruction in them, which allow you to communicate to the panel which will review your proposal these 5 points: the background, the motivation of the proposal, what you want to do, the experimental plan, and sorry. And so point 4, explain why this works calls for access of SESAME. This is a very important point that we will see later. The references. It's very important that you fill this file in a proper way without changing. So, example, when it is written at certain point, do not change anything above this line. Please do not change above that line, because otherwise the program which takes in charge the proposal will not work properly, and you will have to work again. So in total, you have to fill something in the user portal. This is online information. Then there is this download template with all the proposal. And then there is the safety form, which is another mandatory important part, which you also download, which tells us about the nature of the sample. And this is mandatory. You at least have to fill, if you have more samples, you can have many safety forms, obviously, but if there is no safety form uploaded, you will not be able to proceed with the submission process. What to do in order to come? One thing is consult the website, discover what we can do, and also please do get back with the Beamline scientists. So I would say that actually the first thing that you should do once you have an idea, after having the website and what are the things that can be done, then the first things to do is to discuss with the scientists about is it technically feasible, what I am asking for? Do I need to bring some instrumentation which is not available at SESAME, or is the dotation of SESAME enough for that? Discuss with them how much time will your experiment last. So of how many shifts to ask. We are working in shifts of 8 hours. This is the unit of time Then, about the information that you have to give to the reviewers, background and impact are obviously very important, because remember that reviewers will have to read 151, 200 proposals. The more clear you are, the better it is. If you a proposal which is lacking in in details about why you need a synchrotron radiation beamline to do the job. Why can't you do it in our laboratory? Is weak. Is very weak. Now this is a very important point. But also give to the panel. Understand. Remember that the panel members are scientists in different fields, but they don't know everything. So you have to ease for them and go to the core of your experiment and explain why it is important and what is the impact that this will have and what kind of advancement and projected publication you can obtain from that. Yeah? So in how you write up your proposal, think of it as an article for a wider audience than only the specialists in your field. So fill with a bit more details and stay to the basics. So what is the process? Once you have hit submit, then three things are at our side. First of all, the safety officer looks at the safety forms and checks that everything is all right, or sets a flag alert in case of any risk. Then the Beamline scientist will say if your experiment is feasible or not. And this is the point in which it becomes clearly important that you speak with them before. Because if you assume something which can be done and is not feasible at the moment, or will never be feasible, for example, you don't know, and then the technical feasibility is just a threshold. The Beamline scientist is not involved at all in the scientific decision evaluation process. He will just say if this is possible or it's not possible. And the moment he says it is possible, he is actually taking the responsibility that he will be able to carry out your measurement. So the best thing to do, again, is speak with the Beamline scientist before submitting a proposal. And the third is a panel review committee, which will evaluate all the proposals and put them in a list according to the scientific merit of it. And this is the present members. All these information together with the user policy, the data policy, you can find them on the website of SESAME, and this is the present committee members. As they pointed out, they are too few. We will have to increase the number because 151 proposals with 2 proposals means, with which 2 reviewers at least for each proposal means each one of them has a month to review 20 proposals, which is a bit too many. It's because it's not terribly different from reviewing an article. So we will increase this number in the near future for the next fall. And once everything is set, you will come. You will be hosted in our guest house, and which is really brand new. And is 50 meters away from the main entrance of SESAME, and you will do your experiment. After that, you will be still asked to do mainly 2 things. publish your results in due time, obviously, and with a much shorter deadline, fill the and final report. So the best is the customer satisfaction report of the beam, of your beam time. You will be asked how was the beam, how was the beamline status, how was the level of support, how was the guest house, etc. This helps us in benchmarking our operation. Failing in the best will not allow you to fill a new proposal for the next call. Failing to publish not, obviously, because a publish can be much longer than the interval time between two proposals. But obviously, and this happens sometimes, are coming to measure, even with very good results from the review panel, for 1, 2, 3, 4, 5 times, and now nothing comes published. At a certain point, a flag is lit, actually by me, at the level of the review panel, and then you might be asked why this happens, or you will simply be not allowed to present a proposal for that call. In publishing, we require you to acknowledge the effort of SESAME and acknowledge the one, if any, one of the various funding ways that we have to support the travel and the hospitality of the users to SESAME. We have several programs which are funded at different levels, which allow us to accommodate at least at the moment, all of the scientists for member. Then we will see for the future for non-members. But at the moment, we are able at least to support both travel and accommodation for all member scientists. And this is what I wanted to say. Yes.
Thank you very much indeed, Andrea, for this very detailed presentation. At this point, floor is of course open for questions, comments, and queries. So please, Dr. Garaibe, please ask your question.
Thank you, Andreas, for this information. Really, it's very helpful. I have experience of writing many proposals to synchrotron facilities. Not all of them was granted, but the good ones has been accepted, which is good for me and good for anyone who will gain proposals accepted by SESAME in the future, because it's luxury times that one can have it. Some technical questions that I would like to ask, just to clarify for anyone will ask me later or in the future, I will do it, is the work limits of the proposal is it like maximum of 2 pages, 3 pages, or it's unlimited?
No, it's 2 pages. It's a fixed format. It's a fixed format.
2 pages. Yeah, 2 pages. And about the safety form, that it is mandatory to be submitted. Is it online procedure, or it is there is a form offline you have to fill it and then upload it with the proposal?
Offline, you download it, you fill it, and you upload it.
Okay, it will be nice in the future if it will be online, because sometimes it's really very, sometimes it's very difficult, because many information maybe Not for us, especially when you are using chemicals. Sometimes you do not have enough backgrounds about if it is safe or not safe and how to deal with it. So when it is online, sometimes it's easier because your database will be very helpful for the others to fill this type of forms.
Yeah, did I mention some slight problem of lack of staff?
Yeah, I know
Yeah.
that. I know the problem. It's really, I know it's very hard. But,
Yeah, it is.
Yeah, but SESAME is a new synchrotron facility, so we will.
Yeah, we are really very young.
It's very acknowledgeable, so really.
Yeah, we most of that you see is imported actually or and adapted from other synchrotrons. This was the most economical way to do it, not only from the point of view of money, but especially from the point of view of manpower.
The last question is about the users when they come into synchrotron. So you know, it is accelerators and high voltage systems and many things. So they will have some safety training before they can do it online, or only on day one they will have this safety training?
Oh, good question. Thank you very much. We are moving to that. Thanks to IAA, we are starting online tutorials for many things. We'll be ready, I hope, for next spring, so that people can actually have this tutorial before coming already.
Excellent.
So it's spares time once you are here. It will be obviously, like everywhere, a tutorial which will last for 1 year or something like that, and you have to repeat it with questions, random questions which change every time. But it's yeah.
That's good. Thank you.
Thank you.
Very good. Further questions, comments, or queries? Dr. Hannoun.
I want to ask you regarding the tomography beamline, when it will be open for proposal submission?
Well, the Beamline should be open to users in 2023. And there will be a round of so-called friendly users. This is a practice that every Beamline in the world does. So before there is a benchmarking with real samples of friendly users. So there might be some possibilities before here, but then that will depend on Gianluca and how he's planning to use that beam time. Essentially, it will be open in 2023, and I think that if everything is well, and we are now having a call in March 2021 for beam time from September 2021, and then counting 1 year from there because we really need so COVID makes these calculations a bit complex, but essentially I think that if everything goes well, in September 2022 there will be a call for measurements from January 2023, and that will be the point where you can aim at placing your proposal.
Yes,
we would like to stay in register with the year, with the semesters, but have to fight against the current of COVID in the moment. Yeah, so we're trying to put things in order. It won't be so easy, but we will do our best.
And I want to ask you about the shifts that will be given. How long are these shifts? Is it 24 hours, 72 hours? And is it continuous shift? Is it like 8-hour shifts? will it be open during the night time or no?
Yeah, yes to all. So it's 8 hours everywhere, or every place I know, actually. 8-hour shifts, mostly running 7 days a week. Then every week, normally there is 1 day of machine, which then is chosen in order to be fair with the machine. 1 Friday, yes, 1 Saturday, 1 Friday, 1 Saturday, 1 Friday, 1 Saturday. So in this case, everybody has only Fridays, or not everybody has only Saturdays between us, and try to go on with a run which will last a couple of months. Then they shut down for installation, repair, and so like every machine. So we are aiming at 4,000 hours of user shifts by 2023, which is ambitious with the amount of staff that we have, but I hope that we can cope with that.
I want also to ask you about the accommodation. So, is there any detail for the accommodation, or it will be dependent with the proposal for the availability, for the
priority will be given obviously to members, but there are 48 rooms. It's a gigantic, with respect to the number of beamlines, and it has been built with a very long time span, this guest house. Considering the fact that Alan is far away from Amman, so it's 3/4 of an hour car, staying in Amman is not so much convenient at the moment, and there are no hotels around here. So it was of paramount importance to have a guest house with a large possibility of hosting users. And 48 rooms are, because at the moment we have 3 beamlines working. Even with 6 beamlines working, I don't think that 48 users at the same time on site. So I see a very good margin there.
I want to ask you also about the data ownership. Will SESAME have the like a dual ownership with the user, or it will be like the data like solely owned by the user? He have control over it.
No, I mean, the owner of the data is the user, not SESAME. We do our data policy, which you find online, says that we apply for the open data scenario in which data are kept by us a certain number of years. During that certain number of years, only the principal investigator can access for them. After a certain time, they are open to everybody in order to participate in case to further use of those data, because it's data which has been obtained public money, so it is at the end, after a certain amount of years of embargo, they will be of everybody. Still, the principal investigator has to be informed when somebody asks for the data to be given.
And my last question is, I want to ask you about the finances. Are these costs covered by SESAME for the use and also for the accommodation, or the user shares some cost with SESAME regarding these things?
Well, this is under debate in this moment, and I can assure you that members have the accommodation and the travel covered at the moment. because did I mention the lack of funding? No, staff and funding. Okay, we are trying our best, obviously. We and the users have to cooperate as much as we. This is our goal, to have users here. So whenever possible, but in the policy, we will have to say at the moment that members can obtain for free the travel and the accommodation, and then nothing prevents them to extend it if it's available. In this moment, actually, the situation is very favorable because the funding for travel and subsistency of 2020 has obviously not been used. So they are there, saved in the bank for future users. And continuously looping in and trying to get more funding, but the amount of things that have to be done with these funds is quite substantial. Yeah.
If I may interject also, just to note that in relation to many other synchrotron radiation facilities, including in Europe, the SESAME guest house is, I think, by far the most comfortable. And the situation, of course, on a more serious note, in terms of transnational access and travel funds for users accessing synchrotron radiation facilities, that is currently being discussed in organizations like ESUR, which is the European Synchrotron and XFEL user organization. There is a distinct lack of funds for travel to various synchrotron facilities. So in this sense, as Andrea mentioned, and he's of course best placed to comment on this, the situation in terms of travel support to SESAME is really quite optimal compared to even European and international scene. And certainly, as I mentioned, on a lighter note, the guest house is extremely comfortable. I would say one of the most comfortable synchrotron radiation facility guest houses that I have stayed in. So it's a wonderful opportunity. Further questions, comments, either from Dr. Hamilton or others?
I have one comment regarding the accommodation. Is from my experience with when I go to Synchrotron Soleil in France, the accommodation there in their guest house is 30 euros, which is really is not that much. So I'm expecting if there will be any charge for accommodation in SESAME, will not that be expensive, like 30 euros for 1 day. So food is, I think it is not that expensive. That's offered by SESAME, and I stayed 3 nights in the guest house of SESAME last year when we had a meeting. And really, as Andrea said and Kersey said, that really it's very comfortable. For traveling from the airport to SESAME, I think it's by taxi, it takes like 40 euros, which is maybe a little bit maybe expensive or not, I don't know. So I don't think that's even that expensive, but it's the most difficult for traveler users is the air ticket, which is, it depends from where he is traveling. For us from Qatar to Jordan, really it is expensive, the air ticket, which is about, I think it's about $1,200 it costs us in the summer. So, wow. But, I don't know why. It's only from Qatar to Jordan, it is expensive. As a Jordanian, when I travel to Jordan from Qatar, it cost me 4,500 riyals, which is $1,200, which is, I don't know why, it is only 3 hours of flight. So
Yeah, it's very
I don't know.
strange.
So it's just expensive just to put you in on how much you will pay if you will go to pay everything. But I know that for experiment, it's free. To do your experiments is totally free.
That is free for sure. Yeah, but that is obviously there is no unless you are in industry, you know, then we can discuss a bit.
Yeah.
But if you are doing research, academia is obviously for free. This is.
Dr. Hanoun, you had a further follow-up question or query?
I just want to know, is there any memorandum of understanding we need to sign it here in Qatar University with the SESAME? Because like maybe a couple of years ago, when I requested to create account, they just defined Qatar University, and then they created my user account in SESAME. So after that, when I want to use, is there a memorandum of understanding, or that's it? I just need to apply for a proposal.
You just need to apply for a proposal. There is no need of standing for a user institution to come to SESAME. No. If we want to go further, then a memorandum of understanding would be nice. We can have a non-binding memorandum of understanding in days.
And this is, of course, something that is an important consideration given what was outlined in terms of the situation. The access is open for individual users, as Andrea mentioned. Then there are examples of other organizations, including in SESAME members, having memoranda of understanding, including the Cyprus Institute that we are hosting this meeting from. Of course, then there are the further discussions relating to other developments, how access and support can be expanded. And certainly there are advantages in membership of SESAME. Clearly, the travel funding being a substantial cost by the sounds of it, particularly from Qatar. Other comments, questions, queries at this point? We can, of course, continue further discussion in the next sessions to come, but particularly inviting questions now relating to user access, beam time proposals. Are there any further questions before we take a small break and reconvene again for the sessions on the further discussion on applications together with the Beamline scientist and the user policy discussions with the project coordinator and SESAME scientific director. Are there any further questions at this point, particularly relating to beam time proposals, discussions on how to construct a winning beam time proposal? It was a very lively discussion. Thank you very much indeed for all the participants for your questions. Of course, thank you very much, Andrea. Dr. Lauser gave a very clear outline on how to write those successful beam time proposals to secure beam time at the Beamline as well as other Beamlines at SESAME. So let us take a short 5-minute break to catch a cup of tea or coffee or something else to refresh yourselves. We reconvene again at Qatar time at, let me just check, at 12:15 So Qatar time 12:15 in about 5 minutes. And we're sorry we cannot offer you tea or coffee on this occasion, to be continued in person when we're able to come and visit you in Qatar. So see you shortly.
See you. See you.
Okay. Welcome back, everyone. We will take a few moments to reconvene. And I'm happy to see that there are at least some cups of coffee or tea, regardless of us not being able to treat you for some reference. Oh, very good. Dr. Garaibe showed us also some other treats. Wonderful. So we are living through strange times when we have meetings and we have to go to our own kitchens to provide the coffee and tea breaks, but we shall prevail and manage. So I hope you had a moment to get something to refresh yourself, some refreshments, and now we have the pleasure to move into what was initially planned as breakout sessions, but as Dr. Garaibe suggested, and I think this is a very good suggestion indeed, and I know Axel agrees also, so let us have them back to back rather than separate rooms so that we can all discuss the various aspects. So we could start perhaps with a meet and greet with the Beamline scientist, Gianluca Iori, from whom you of course heard yesterday, as well as other scientists, other people who are experts in tomography and or using it in specific research domains. So we have Gianluca joined by Dr. Alexander Rack from ESRF, and of course very much involved with the BEATS project. And you heard a presentation from him yesterday as well. Joining me on this part of the session, and of course Axel and Andrea are here with us too. So let us start with the application side, and then we can further discuss user policies with Andrea and Axel. Gianluca, would you like to start by saying a few further words of introduction to yourself, and then we can take this more informal part of today's meeting forward. Feel free to interact and discuss and ask questions ranging from practical to more scientific and so on. Gianluca, over to you.
I didn't expect this. So you mean about myself personally, my background and...
Yes, why not? I think meet and greet is all about that. Just meeting the person behind the presentation, so to say, if you do not mind.
Yeah.
Of course, you can take it to another direction as well. You would normally be in a breakout room with a few participants, but I think given also what Mohammed suggested, I think it's a nice opportunity for all of us to discuss together. So you can take it in any direction you wish, and
Right.
would have done in your breakout room as well. So please.
So I would, as soon as possible, leave this to questions and further discussion. But a few words about myself. So I'm a mechanical engineer. I have a background in mechanical engineering. So there is a whole part of X-ray physics that I studied during the PhD, and in part is new during this project or during the design of beats. But I started using computed tomography data already several years ago during my master's. I worked in biomechanics, so nature materials and mainly bone tissue. I did that for my master's and then for my PhD at several length scales. In fact, one of the beauties, I believe, of computed tomography is that at each scale, from the macroscopic level of a whole bone down to the nanometer scale of nano-CT, which is what they have at the ESRF, for example, there are different structures, different features that one can analyze and learn from. Yeah, what else? The work is very diverse right now. So we are dealing with the design of the hardware, from the microscopes to the sample stage, sample environments. We are trying to learn as much as possible from potential user communities. This is why I think these meetings are very important. I think yesterday I showed 2 examples of sample environments for mechanical conditioning of samples and thermal conditioning, but there are way more, as it was shown this morning as well and again. So yeah, that's something we would also like to learn from the user communities, which sample environments they are interested in and expert in. And yeah, that would be it from my side.
Thank you very much, Gianluca. Could I also invite Alexander, Dr. Ak, if you would like to say a few words in a way of introduction in the, let's say, meet and greet setting?
Sure. I hope after the experience yesterday, today, everyone can hear me well.
We can hear you very well.
Super. So my name is Alexander Rack, as already said. I studied physics already a while ago. Actually, for my master's thesis, I was doing theoretical physics, simulations. And then for my PhD, I had the chance to do something at the Bessie light source in Berlin, Germany, also to work on a beamline where microtomography with synchrotron radiation was established. That was a great chance, which I grabbed immediately. Otherwise, I would have ended up the rest of my scientific life in front of a big C code. And I'm still doing that up to now, and I never regretted it, I have to admit. So I worked as a PhD at Bessie, at the BAM, which also Gianluca, I think, used as a user for hard X-ray microtomography. Then I moved to the Anker light source, also in Germany, in Karlsruhe. It's a bit of a sister facility, I think, for SESAME, because I think at least the experimental hall building is precisely the same, because I think SESAME and Anker share one of the former directors, Einfeld. And after my first postdoc at Anker, I went to the ESRF, first to the microdiffraction microspectroscopy beamline ID22, and since 2010 I work on the microtomography beamline ID19, which I'm now also heading as responsible. Yeah, so I think I have almost now 18 years of experience. My first synchrotron microtomography beamline was, I think, September 2002. And I still remember that, and I still enjoy that. Yeah, so I hope basically with our presentations and with basically also some questions we can further motivate and excite you to join that game. As I said, I'm almost doing it now for 2 decades, and I'm still excited. Yeah.
Thank you very much indeed, Alexander. And just a very few words about me so we get to those important discussions and questions from you in Qatar. My specialization lies in the domain of human bioarchaeology, so we look at remains from the past. And I have, in my meanderings through various tomography beamlines, gone through a set of them in ESRF from ID 19, ID 17, 16A, including also some data capture at BM5, but also in facilities such as the Swiss light source at Porsche Institute using typography there at the CSAC's Beamline. So now it's time for the discussions and questions from you. We are here to answer and discuss with you any question indeed that you would like to explore, whether it is specific aspects relating to applications that you would like to explore, looking at feasibility of particular type of studies using the BEATS tomography beamline, or indeed any other topic that you would like to discuss with us. Is there any immediate questions or topics that someone would like to open the discussion with? In this case, to give you a little bit of time to think about the type of aspects that you would like to discuss, Gianluca, could you outline a little bit more the type of studies that could perhaps be some of the first in the BEATS beamline, perhaps the type of studies that could be ideal for a friendly user phase, or indeed if you have some questions to the Qatari participants relating to what type of needs they would have, so that you can also inform yourself about the needs from Qatar of your beamline.
So I'm trying to share my screen. Can you confirm to me
we
that?
We can see it.
Yeah. Okay. So these are some slides that we prepared in a common effort with the work package 2 of BEATS, which is responsible for the sustainability of the project and understanding the whole and resolving the whole the full potential in terms of scientific applications of a beamline for tomography in the region. So the first slide is meant exactly for this. So to just give an overview of the possible domains and of the possible studies. So what we did was to identify 4 big fields of application, which you see here. So we have material science and engineering, and as case studies, we for example selected the study of light materials and alloys, for example under stress, or energy materials research, which is batteries or fuel cells. I think Alexander yesterday showed very nice videos of time resolved studies in this field. Then, of course, we have health, biology, and food, which means the study of any biological tissue, for example, mineralized tissue or tissues from the musculoskeletal system, which means cartilage, tendon, bone, skin, and so forth. Implants, dental and bone implants, also covered yesterday by Alexander. And then there is soft tissue imaging, which is a broad field as well, lung imaging, brain imaging, and so forth. We have bioarchaeology as well in here, and food science. So also interesting, for example, for food process engineering. Then I think, Kirsi, you are more entitled to explain us or to talk to us, as you have done yesterday, on archaeology and cultural heritage. And then we have, of course, geology and environment, as it was covered in depth this morning. So these are the main areas that we identified. Then, of course, as Andrea mentioned, SESAME might be open and is eventually open to services to industry and the private sector. Then, if you have a specific question or interest in one of these fields, I can show, depending on the interest, some case studies that we collected. I wouldn't go through all of them right now because I don't know exactly how to tune this.
Are there any questions or comments at this point to Gianluca? Any particular area that anyone of our Qatari colleagues would like to explore? In that case, I would of course urge you to get in touch with Gianluca directly and discuss further details with him directly. Alexander, would you like to say a few more words about in terms of applications and the type of collaborations that you've been involved? Of course, Beamline scientists are very much often in a position where a lot of translation between different fields have to take place, so to say. Users from all different domains come and finding also the common language to discuss together applications and what exactly needs to be done in terms of the data acquisition is a process that takes place often in Beamlines. Alexander, would you like to comment a little bit?
Yeah, maybe a bit. My personal experience, and that's why I was very happy and also confident that BEAT will be a success when I follow tomography, or let's say in general imaging beamlines around the globe. Usually these beamlines are sooner or later very successful because X-ray imaging is a robust technique. Yeah? I mean, in the end, what we are doing is we are using classical microscopes which combine with a scintillator to do X-ray scintillator imaging. So who knows how to use a light microscope or can use the field of view of a light microscope in his lab, and that's almost every scientist can do, can also use one of our synchrotron imaging beamlines. Technique is robust. Data processing, let's say, or at least to get a picture, is also rather straight. So that way, I'm pretty sure that also BEAT will build up its user community, and in that way, it's because X-ray imaging in general is so broad. Yeah, I think that the Beamline is not targeted at any specific community, so it will basically cover the needs of the life science people, of the material science people that is interested to do things in cultural heritage. What is important, that's why this event is so important, is that basically the people know in advance, get a flavor of what will be the advantage of going to BEATs for synchrotron imaging, and then basically do their research there. And then, yes, basically the important thing is to discuss with the Beamline scientists or either from BEATs or with us in advance, basically to make clear what is possible and what not. Where are potential hiccups? And I mentioned yesterday already one thing which is maybe a bit unusual when the first time you think about X-rays is the aspect of dose, because usually we learn in medicine or in school X-rays are non-destructive. Yeah? That's only partially true. When you come to a synchrotron, for example, dose can be an issue. Your cultural heritage sample, which for example has a beautiful color, if you put it in a white beam, the color will disappear, even if the sample is still there. These kind of things, of course, need to be discussed in advance. But otherwise, basically, I see imaging beamlines usually as something very nice, yeah, because usually they can easily adapt to the needs of or much more easy adapt to the needs of the users.
Thank you very much, Alexander. Any further comments on this front from our participants? or shall we move then towards the user policy discussion? And at this point, I would like to pass over to Andrea and Axel in terms of moderating and chairing this part of the session. So we could take as long as you wish now, let's say 10, 15 minutes or so, and then we can move to the final discussion and closing remarks from Professor Ilham Al-Qaradawi. And I'm sure our project coordinator, Axel, you will have also some closing remarks to make. But firstly, over to you, Axel and Andrea, to discuss further user policy. And of course, as a equitable measure, as we did with Gianluca and Alexander, perhaps you wish to say a few words about yourselves in the context of meet and greet, as much as we can do that online. Andrea, you are mute.
Okay, yes, sure. So I came to synchrotrons from a different field, actually. I had a past as scattering of helium atoms from surfaces, which is this is the most surface sensitive technique. So for us, electrons were deep space probes. In comparison, a helium atom doesn't even enter the surface. It's repelled by the electronic charge of the surface, and these are normally used for getting the surface phonons, essentially the same use as neutrons for getting the bulk phonons. But some crazy people like me at that time tried to get also structural informations about surfaces from this, and it is particularly complicated, complex, difficult to get it because you don't have a clue about what is the interaction potential. Believe it or not, we don't know exactly what is the shape of interaction potential between atoms. So we have something for very simple systems, but if you are thinking of helium atom hitting a gold surface, you don't have really a model potential. So I worked on diffraction in this way, and at a certain point, Electra opened the position for diffraction. Oh, now, being Trieste my hometown, I couldn't believe this possibility of having a position in my hometown. And so I applied, even if my experience was absolutely nothing to do with X-ray diffraction. But at the end, I had that position, so I started as a staff member at the diffraction beamline, the only diffraction beamline that was there, because Electra is a low energy. At that time it was only 2 GeV, then it went up to 2.4. But so we used the Wiggler to produce. Actually, we built a beamline. That was the first beamline I built as the boy in the team, and then we went on and tried to find out my way in other fields, and so I devoted a lot of time in scattering techniques and in atom holography with atomic resolution, which something that was much tried mid-90s in synchrotrons, and it is now something that can be done with free electron lasers, but you didn't have enough signal. The signal to noise is horrible, so you didn't have enough signal to separate the Patterson function just by that easily. Then beamline after beamline, I became also a beamline builder. So I constructed, the last two beamlines that I constructed were the two Indo-Italian beamlines at Electra. It has a very open business model. Differently from other synchrotrons, there are half of the beamlines built in cooperation with other institutions. So this is the way in which Electra succeeded in reaching 20 beamlines, even with the funding from the Italian government, which in Europe are legendary low for science. And so the last two were these two diffraction, powder diffraction and macromolecular crystallography diffraction beamlines built together with the Indian Institute of Science in Bangalore, of which I was the responsible of one of them until when I came here as the scientific director. And after 18 days of being the scientific director in SESAME, I started my first lockdown, and I am now in the third one. So it has been an odd start. As I told you yesterday, I was planning to come to Qatar very soon after. It was something at the end of March, if I remember well, or at the beginning of April. That was planned, and it all went off. But we discovered this use of Zoom, yeah. So with Beats especially, we are having quite a number of meetings per week, if not, but per week for sure. Quite a number of them, and we are keep going. Yeah, it's mail-in is working more or less. It's complicated, the customs and things, but we are trying to get over, and it will end at a certain moment. So this is my background: helium atoms hitting a metal surface.
Thank you very much, Andrea.
We can never imagine it here.
Yeah, my background. I am from education an experimental solid-state physicist. When I did my studies, the master's was still called a diploma thesis, so you can calculate how old I am. I did this in '86 at the University of Dortmund in Germany, but from the beginning, as an experimentalist, I always worked with synchrotron radiation. I didn't do a single experiment in the laboratory. I did my PhD at Hasilab in Hamburg on the electronic properties of matter, pure basic research to build better semiconductors and things like this. You might have applications 10 or 15 years afterwards. And after several stations in different synchrotrons in the world, I ended up at the ESRF, where I shifted gears from the execution of science and scientific experiments, during which I, like Andrea, built several beamlines or participated in the construction of several beamlines. And I went into the, let's say, administration or feasibility of science. And I took the position of the head of the so-called CRG liaison office. You know, the model of the ESRF is that we have 30 beamlines which we operate there on our accounts, but we leave the beam bending magnets free for collaborating research groups, hence CRGs, who are from the member states, who build beamlines there, and who come with, let's say, a lot of staff which has no clue about the procedures and the usances at the ESRF. So you need to support them properly to have an office which looks into their needs, helps them out, and makes them, let's say, get access to the ESRF resources as much as possible. This I did for some 18, 19 years. And then came the idea, why don't we enhance our forces a little bit when it comes to European projects? And being a bit closer to retirement, you become, you will see this later, a bit crazy. And then I started to interest myself in this high-risk project, BEATS. I mean, to build a beamline in Jordan is not what we do all day. And this is something which sounded so appealing, so let's say challenging, that I couldn't hold myself. We got, of course, good support also from the European Commission. And we brought together this consortium that I showed you yesterday. And I must say, the experience that I made in the past 2 years, or let's say a little bit more if you count the proposal writing phase, is really rewarding. I mean, you can imagine the problems that we face also on the technical side, but then even, let's say, worsened by the COVID situation. And as Andrea just said, we made extensive use of Zoom, and we brought together, despite all these problems that we have, a really effective, highly motivated and competent core group within this consortium, who up to now has not to defend any, let's say, substantial delays in our initial planning, which was done before COVID. So we are still on track with hiccups here and there. I won't hide that, but we are still on track, and we still, unless something further destructive happens, will probably face deliver the beamline in, let's say, end 22, beginning 23. Depends always on what you define as deliver. But it is a nice and wonderful experience to do this. And I can only, let's say, recommend to reach out to new cultures. People in the beginning always thought, oh yeah, this is the well-established, pompous synchrotrons who now finally tell the newcomers and the smaller ones how things are correctly done. This is exactly not the spirit. It is a mutual knowledge transfer. And what I learned in these first 2 years on, let's say, strategies or attitudes on problem solving, they are a bit different at SESAME than they are at the ESRF, yes. But this also has to do with the resources that are there and things like this. But they are not less efficient. So we can learn mutually when it comes to, let's say, crisis solving. And this is what we do, and this is what I enjoy in this endeavor. So in the discussion, if there's something concerning EC or EU projects or project management, that would be me. But the SESAME user policy, access, etc., that is Andrea. We are open for questions.
Thank you very much, Axel. So over to you, Andrea, on user policy and so on.
Yes. What do you want to know about the user policy?
Any questions from the audience, from our Qatari participants? We have, of course, already discussed quite extensively user access and touched upon also the user policy issues, whether it ranges from data to travel support to other aspects. But is there some further questions that need to be addressed or that you would like to discuss? Professor Al-Karadaf, please.
Good morning, everyone, or good afternoon now. Thank you very much. Can you hear me?
Yes, we can, loud and clear.
Yeah. Thank you for everyone for this very productive discussions and lectures and really enlightening questions and presentations. I have a few questions, and it stems all from all my different passions and my different hats. So we have maybe discussed already a lot about research, which is really important, and of course I'm very interested in it. But what always comes to my mind also is looking at the other benefits of having such a facility. It's really a privilege to have such a facility and such a project in this side of the world. And we've been working for a long time on trying to be part of SESAME since maybe 2005. I have worked with Dr. Samar Hassanain and Sir Chris Lowen Smith. I think the best thing is what we're trying to do now is to work from bottom-up approach and start with the users, and then hopefully we achieve membership at some point. But my thinking now is that we need to, since this facility is in the region, we need to have more visibility of such facility and make it available not only to researchers and to large grants and proposals, but also to students, like use it for teaching, for example. So we can have it as part of a course for example, we have at Qatar University a material science master's course, and they have a material science experimental, which we introduce them in to all the facilities we have at Qatar University. But I would think having, for example, 1 week to spend in SESAME or in BEATS to do a few experiments. They are not necessarily research experiments, but rather experiments to get to know this kind of experimentation and this kind of material science and surface science. What can they measure with this? And all these wonderful applications everyone has talked about, how can we apply to all this so that when they reach the level or the stage of using these facilities as research tools in their future research, they have already been introduced to it. So this is one thing. The other thing is using this facility as well in the same way that CERN opens itself to many different areas of the society. And here I'm using my hat as president of Qatar Physics Society. So, for example, having 1 week or a few days for teachers to come and have a course on what available facilities are there, or even for students, whether they are university students or school students, because the only way we can have research and science being known to our youth is by introducing them to such facilities. Whatever we tell them in books is not really going to have a great effect if they don't go, hopefully when we can travel again very soon, and see such facilities and know exactly what they do. And maybe they will not be able to do experiments, but at least they can see what experiments can be done in such facilities. So the question maybe to Dr. Andrea Rausi is, are such things possible using SESAME or BEATS as research tool, as teaching tools, and having visits from students and teachers and so on? Is this feasible?
Andrea, over to you.
Thank you very much. Not only it has already been done several times, actually. So I came here in June 2019, before even thinking that I would have applied for this position, as chair of an environmental science school. It was part of something which was the Open Sesame project, which was in turn a large project which was funded by EU and led by ESRF again, like Beats, which organized 4 schools on different arguments at SESAME with hands-on experiments. Roughly 20, 25, 28 students per school coming from countries. That was reserved for members. That is one limit of the module. But and last of these 4 schools was looping in with Hercules. So there was a part of Hercules school. Hercules is the has a long tradition as the school for synchrotron radiation in Europe. It was born in the SRF, and then it was partially exported to other laboratories in the last 10 years. So there were sessions of hands-on also in Electra and in other synchrotrons, but still it was essentially something which was created around SRF, and which made, I think, a large share of what are the Beamline scientists and the user community in Europe, year after year. We're speaking of larger numbers of students and coming. Then there is the ICTP school, which is held every year in Trieste, with hands-on in Electra. And 2 days before leaving Trieste in February, I had a chat with the director of ICTP, and we made a memorandum of understanding signed when I was here to import here that module. So it was a funding request for ICTP to help us in setting up schools in SESAME, which have been linked to the schools of ICTP in Trieste about synchrotron radiation. With hands-on, we have this guest house, of which we have spoken so much already, but really it's an asset for these kind of things. And it means that there are 2 things which are extremely easy for us. There are many things which are extremely difficult for us, but 2 things in particular are easy. To keep the machine on, because with a solar plant, we don't spend money for turning it on, because the energy is for free, comes from the sun. For free is maybe it's an overestimate, but it's essentially for free with respect to what any other synchrotron facility has to pay around the world. And hosting people comes at no cost, or almost at no cost. If there is no user beam time, all those rooms are free, empty, and can be used for students to come. And in June, it was not possible. When I was the chair of this School of Environmental Science, June 2019, the guest house was not yet open. So we were in a hotel in Amman and had to take a bus every day. Me, Sakura, all the other teachers come up here, do the lessons, do the hands-on, and every evening returning down to Amman, downtown. But now it's not. You can really have an environment in which we can invite teachers from Europe, teach ourselves, so the staff of SESAME, the scientists of SESAME, all together. We can invite students from everywhere and have them here and teach. So I think this is actually what you are asking is also one of my priorities in how among the things that have to be done in SESAME. But we are not going to do it immediately now. So what I offer you is what I offered already to others. It has really no cost. We can give you a few lessons on distance on how a synchrotron works, what is EXAFS, what is tomography, and so on and so forth. We just have to find out a suitable period, but it can be done at practically no cost. Zoom.
Thank you, Andrea, and thank you, Professor Al-Qaradawi, for this important topic and opening this for discussion. It is indeed very important that we introduce students and train students early on and inform them about the possibilities, but also provide multiple different types of opportunities to explore these. And I'm very happy also to hear about what Andrea outlined in terms of the Zoom lessons. Perhaps you want to comment further, Professor Al-Qaradawi, on these ideas, or indeed if you wish to follow up on those. Certainly some of these aspects have been tried also in the current SESAME members, and what I personally have found works very well is in some of our advanced level doctoral student courses. We give them introductions to the synchrotron radiation, some of the techniques, and then actually involve and bring these students to SESAME within our beam times. But yes, please, if you would like to discuss further and comment further on this very important issue on training the next generation of synchrotron users. Professor Al-Qaradawi, please.
Thank you very much for your answer and for the clarification, Dr. Chrissy. I think this is really important, and I'm very pleased that it's already happening and it's already a priority for you, Dr. Andrea. I would be very happy to discuss this for Qatar and maybe use the current time where we can't yet travel to agree on some methodology or some plan of how we can do something like this, as well as for sure having online courses and so on. But I think as well as using the facility by researchers, it's just as important, if not even more important, to introduce it to the younger generation and to the teachers so that they can introduce it to the younger generation, so that in the future this would be even more beneficial to the region. So thank you very much.
Dr. Garaibe, please.
Just a follow comments of the question of Dr. Qaradawi and the reply from Andrea is that, about maybe one of the informative information for people here in Qatar, which is the user meeting of SESAME that's happened every year. That's meeting with the personally with the others about what they are doing and what are the future. It is one of the, we can consider it as a conference that researchers as well, maybe students can attend and listen and get some information. As far as I know, that some of the synchrotron facilities also, they are supporting students to have their projects, graduate projects in facilities, not even in research like electrical engineers or mechanical engineers or IT people. If they are interested to have some participation in such accelerators like SESAME, I think it is it can be available also, but the problem is for the instructors is to find some fund for these students to travel and accommodate them during the summer break to do their project there and come back with their information and write their graduate thesis or whatever is required from that department. So this also is feasible, and the other things is maybe possible that to have a conference about SESAME here in Qatar. Andreas, he's involved, was with me, with Alp and Dr. Qaradawi about this. But since this COVID-19 blocked this way. So we hope that we can apply through the MPRP in Qatar to cover the travel for the guest speakers from all over the world to educate and give us more information to Qatar scientists and researchers about what is SESAME and what we can do in SESAME. And but unfortunately, this COVID-19 is delaying this, and I don't know. So we missed 2 cycles of this one. So hopefully, next call we can apply, and we get like in a year from now, maybe we will have a SESAME conference here in Qatar in more details, and the other things that we can also get. But this needs time and think more is writing joint proposals, research proposals through the MPRP to see what is possible to do now and in the future using MPRP, like what I'm working now with colleagues here in Qatar and other in Turkey, to get some fund through this MPRP to do some CO2 catalyst experiments. The diagnostics will be done in SESAME. This is our plan. Last year we faced the problem is to convince some of industrial countries here, companies in Qatar. And many thanks to Mariam Al-Aji. I hope that she is listening to me, that she's in the panel now. She provided me with 3 main researchers in 3 companies in Qatar that maybe be possible that we can now again apply in a few months to get this fund and do such research, and mainly the diagnostics, all of it should be done in SESAME using EXAFs, using XRF, X-ray diffraction, what is available. I'm not sure if the infrared will be possible, but in the future when PETS is ready, we can explore our samples using beads. But I think what SESAME now have it, I think is enough for us to do this in SESAME. So there is many ways to communicate, but it's to convince people come and work in synchrotron facility is not simple, but once the people see really the beautiful output of such research, beautiful data, more details that comes out of one single sample, really can motivate the researchers to come to SESAME and any other facility all over the world. That's my comments about how we can get useful of SESAME, hopefully soon.
Thank you very much indeed, Professor Garaibe. Other comments, perhaps Andrea Lausi, you would like to comment on Dr. Garaibe's address and perhaps others also.
Yes. What I would like to comment is that I think to repeat these kinds of meetings also for the other techniques. Also because we have now focused on beads, but also EXAFs and IR and powder diffractions could be highlighted, and also photoelectron spectroscopy and fluorescence with soft X-rays. All these techniques give quite a lot of information on what in. Don't get me wrong. I'm still obviously unexperienced on the landscape, on the scientific landscape of the region, not having had so much chance to travel around and people. I would love to have a clearer vision of what is happening at the scientific level in the region. But from my naive perspective, at least two things are absolutely evident to me, that this is a place where earth sciences, and for obvious reasons, are of great importance, and where archaeometry and cultural heritage is of great importance. So these two lines of research, at least, should be under focus. But most probably there are many others, just simply I don't know yet. So it is not that I would like you to hear me speaking of what we can do at SESAME. I am in need of hearing you about what you are doing in the universities, because only then we will have a complete exchange of knowledge, which is needed which is the fuel that will keep SESAME running and the scientific community to grow. Thank you.
Thank you very much indeed, Andrea. I believe Dr. Caprolat wished to make some comments. Axel.
Yes, thank you. I find this, what we just heard, a perfect and a very good idea. And just as the coordinator, would like to mention that our activities, like what we do here now, should not be limited to beads. We can open this to other activities, scientific activities at SESAME. This is full in the spirit of work package 2 of beads, in the sense of sustainability and stewardship models, if we include also other beamlines in this and make this a way to increase a little bit the attendance of such workshops.
This is very good to hear, Axel, and of course I am very much available for taking this forward also with my colleagues from BEATS and Work Package 2, Frank Lerner from DESI, and first and foremost, of course, Dr. Andrea Lausi from SESAME. But before that, could we hear from our colleagues from Qatar, perhaps, Professor Al-Qaradawi, Dr. Karaibe, and Professor Rausch would like to mention. Professor Rausch, would you like to start?
Yes, ma'am. Just a comment about it would be great if we can have a link between the experiments and the visualization and the data analysis, because sometimes you go to synchrotron microtomography beam time, you do your experiments in 2 days, but you spend like years doing the analysis, literally, because it's really too complicated. So as we have a user community, it would be great to have, let's say, computer scientist community, program or algorithm development community who can develop standards, algorithms, or codes for specific analysis. So from an end user point of view, this becomes routine. So you can just use these codes or these softwares to do their analysis. Because, not most of end users are familiar with programming or the algorithm development. So this is a really challenging task, and I know it's not easy, it's time consuming, it's expensive, but it would be great if this can be done, and I think it will make this Beamline unique among other facilities, because I think now it's beyond just the visualization. Visualization, you can just do your experiments in 2 days or 3 days. You do just nice 3-dimensional images visualization. But what's most important right now, it's just the quantification, the accurate 3-dimensional quantification from these 3-dimensional images. This is extremely important. And there is an issue of sustainability. So, for example, from us, like from a point of view of end user, maybe you can get a project, okay, you can do this analysis, but when this project ends, there becomes an issue in terms of the analysis that you can do. So it is just a comment. It would be great to have this this facility or this capability in your facility.
Perhaps I could ask both Dr. Andrea Lausi and Dr. Haralambos Chrysostomou could also perhaps comment and respond to this. Dr. Lausi.
Well, this part I really would, on computing, I really would like it to leave it to the experts. It's deep water for me, yeah, to swim in. I don't know what are the capabilities in the region. I don't know how to. I wouldn't know from where to start. Okay, no, we are starting from Cyprus, aren't we?
Yes.
Yeah.
So Dr. Chrysostomou, I see Haris is online. So maybe Haris, you can comment and take this discussion item further. Harry, you are muted. At least we can't hear you.
Hello, can you hear me?
Yes, we can.
Yes, this was one of our considerations when we were writing the proposal, even from the beginning, because one of the difficulties is when the users leave SESAME or even any synchrotron facility, it has difficulties analyzing the data. So one of our solutions was to utilize the, starting from Cyprus, which we have available the Cyclone Super high performance computing facility. And because one of the aims for our facility is to serve the area, which includes SESAME and its users, and to make it available by creating and more or less and duplicate pipeline analysis from SESAME here in Cyprus, where the user will be able to request access and to able to use our high performance computing in order to do their analysis. But it's not only the hardware that is available, but to create them like also to facilitate the users in terms of software and training on how to utilize these tools. And then by initially this process, then the user will be able to gain expertise and to facilitate their own research, but also to be able to help other users as well. So I believe that this work, that the last part of my presentation, to use it as a data service, it was to help users start understanding first of all their needs and then how to solve their specific problems by using our resources. And then when they are ready, at some point, either help others or be able to transfer this knowledge back to their institute. So this is like a domino effect where you will help users to help others and then to be able to facilitate this kind of research on their own institute. So.
Thank you, Hari. And if I may add to that as well, an added layer of opportunity, let us say, for users to engage in these processes and learn some of the national facilities. Haris Chrysostomou is also involved here with us in the Biomera project, which is closely linked and even mentioned in the BEATS project. And in this platform, we have a laboratory-based micro-CT as well as these imaging pipelines. And they're the research technical specialist, as well as other members of the team, including, of course, Haris, will be setting up such processes. And indeed, this platform and the project involves multiple synchrotron radiation facilities, including SESAME. And here there are opportunities, and this has also been discussed in the SESAME Council meetings, how we can support users this way and going forward to enable the processing, analysis, and visualization of the data that, as Professor Al-Rauch mentioned, can be acquired in a couple of days but then it can take years to process and years to analyze, and even decades to bring to the publication phase in some cases. Certainly in our case, when we look at things like virtual dental histology, we have data sets that will last us 10, 15 years to the future. So this is very important point indeed. Further comments on this topic or otherwise? And I'm keenly aware that we are running over time, but I see that participants are still with us, so I suggest that if it's okay with everyone, maybe we continue for a few more moments till past, and it would be really a pity to cut this very fruitful discussion that is now taking place. So further comments on this or other topics before we hear closing remarks from Professor Al-Qaradawi and Dr. Caprola. Any further comments on this topic or other? Very good. I think we are then now on the moment in which our discussions within this event are coming to a close. I hope this will be, however, the beginning of a very fruitful set of interactions with all of you. And indeed, I think there were very interesting ideas that surfaced, and it would be very good indeed also within the BEATS project as well as beyond, where appropriate, to follow these up. And we have, of course, the clear support of Dr. Axel Caprolat, as he mentioned. And with this, I would like to pass the floor to Axel for his closing remarks, followed then by the final closing remarks by Professor Al-Qaradawi. Axel, please.
Yeah, Kirsi, I would like to use this opportunity to thank you very much to you and your team for perfect organizing this event. Chapeau, it went well. Although my PC does not like or seem to like this WebEx Cisco thingy, and I tend to agree with it, but that is only a technical thing. I think as well our colleagues from Qatar, it was great to make your acquaintance, and I hope we stay in touch. I can only reiterate the message that we want to get across here. Please, the potential users, stay interested, stay tuned, and stay in touch with us. We shall be there at any moment to answer your questions. If you have any, don't hesitate at whatever moment you might see fit. Thank you very much, and it was a pleasure.
Thank you very much indeed, Axel. Now it is time for the closing remarks from Professor Al-Qaradawi. Please.
Thank you very much. It was indeed a pleasure and privilege to meet all of you, even though not so much in person, but still it was an opportunity to get to know you a little bit more than just a name. And I would really like to thank in particular Dr. Chrissy from the CYPER Institute and Dr. Baraiba from Qatar University. I think they did a great job. They were the main people organizing this event. I'm sure there are many others also were involved, but they did the biggest job. Thank you so much. I think it was really successful. And I do also commend what has already been said, like this is the beginning and it's certainly not the end, but we should just try to keep the momentum going and certainly have other meetings, maybe in a few months or a few weeks, depending on your availability, and discuss further options and further programs that we can develop and use and take advantage of for the benefit of researchers as well as youth and students, whether for postgraduate studies, they can do their research, or for just school students and school teachers to get to know such facilities. Because really, one of the biggest issues is that some students become naturally curious about science, but then when they look at it, they say, what are we going to work? What is the career for this field of study? And if they don't say that themselves, their parents and everyone around them will tell them this: no, what are you going to work if you go into science or into physics or material science? Because most people don't know that there is a career and there are lots of opportunities for such fields. So I think it's our responsibility really to make this known to the general public and to students. And this is the only way we can do this. And I remember when I went to CERN and I was talking to people working there, almost every scientist working there has been introduced to CERN through the summer program of CERN. So this is of utmost importance to introduce the school students in this way, either by running summer schools or even just school visits to such facilities and introducing what these kinds of facilities can do and what research can be done in such facility. So I thank you all very much for your efforts and for your time being there for 2 days continuous and presenting in such an amazing way. And I really look forward to continuing these discussions in the future and to seeing you in person somewhere in the world. And of course, you're all welcome to Qatar soon. Thank you.
Shukran kathir, Professor Al-Qaradawi, for these kind words and very key remarks that you made as closing remarks. It has been a great pleasure to interact with you and your colleagues, and I would also like to take this opportunity to thank you personally very much for all your involvement and support in organizing and bringing this event about for Qatar, and drawing our attention to these very important questions about the future generations of researchers that will be using BEATS as well as SESAME in the future. We hope many Qatari researchers, both experienced and new, will be able to join us. We very much look forward to future interactions, and we will certainly be in touch to organize these follow-up meetings. I would also like to take this opportunity to thank most warmly Dr. Garaibe for suggesting and standing up to the challenge of organizing this meeting together with us from BEATS. I would like to thank all the participants from Qatar, Professor Al-Rawsh, especially for his very clear and most interesting presentation on the applications. And of course, all the team over there in Qatar, as well as the participants for your stimulating and interesting discussions, as well as the BEATS team, both here at the Cyprus Institute and in the various countries. So with this, I would like to wish you all a very good afternoon, and wish you all the very best. Stay well, stay healthy until we meet again. Thank you very much indeed. Shukran. مع السلامة.
Salam.
Thank you very much.
Thank you.
Assalamu alaikum.
Thank you very much, everyone. Thank you.
Thank you. Thank you.